For past year question, June 2019, the question that we are going to discuss are question 3 and also question 4. First, we do question 3. Question A. Construct the appropriate PERT network for the project. Okay, this is how you draw the PERT diagram. First, I want to explain the component for each diagram. This is how we call nodes. We must use number to represent nodes, so it shows that the activity from the table in the question. So each activity must start with a node and end with a node. To connect the node, we use arrows. We tell the activity is being done. For example, you can see the activity here is A10. The dot line is we call dummy. It represents the relationship of the activity and it does not involve any expected time. We will label it as D10. Next we have EET and LET. For each node, EET refers the earliest time to start the activity and LET refers to the latest time to finish the activity. So now we will begin to build the diagram. We start with node 1, which has no intermediate predecessor. Looking at the table here, there is no predecessor for activity A, B, and C. So all these activity is start with node 1. So activity A, duration time is 10. Activity B, duration is 6, and activity 7, duration time is 7. To start activity D, we need to end the previous activity with a node. So in this case, we need to activity A with node 2. After that, we can start activity D with duration time 9. For activity E, we use the same methods as before and we get this part here. For F, if we look at the question, the immediate predecessor for activity F start with B and C. These two activities start from the same node number 1. This situation is called concurrent situation. It happens when two or more activities start with the same node and it cannot end with the same node. For example, is with this B and C. So to solve this, we need to end both activities with different nodes. In this diagram, we end activity B and C with node 3 and 4. So to start activity F, we need to draw a dummy line from node 3 to show the connectivity of activity F, not just coming from activity C, but also from activity B. Following the same method as before, for activity G, we need to end activity D and F with node 5. After that, we can start activity G with duration time 8. For activity H, we need to end activity E with node 6. We can start activity H with duration time 7. Finally, for activity I, we need to end activity G and H with node 7. After that, we can start activity I with duration time 7. To end this activity, we need to end it with node 8. So we will continue to question B. Determine the earliest event EET and the latest event time is LET for the project. For EET, node 1, we must start with it 0. So for node 2, we plus the duration time 10 with 0, which equal to 10. Next is for node number 3. We take duration 6 and plus with 0 is equal to 6. For node 4, we have two durations which are 7 and 6. In this case, we need to take the highest duration, which is circled here as 7. So 7 plus equals 0 is 7. We will use the same method to get the rest of the EET as shown here. For LET, we need to start from node 8, and node must have the same amount of duration as the end EET. So here we will start with LET 37. For LET node 7, we need to minus 37 with duration times 7, which equal to 30. Next, on node 6, we need to minus the duration 30 minus with 7, and we get 23. For node 2, we have 2 LET, so we need to choose which one is the lowest one. So in this case, it is 12, which is circled in the diagram. Using the same method, we can get the rest of the LET as shown here.
So we will continue on question C. For C, the project estimated completion time is equal to 37 weeks. And for the question D, for critical activity and critical paths, we need to choose LET and EET which have the same value. So critical activity are equal to C, F, G, and I, and critical path are 1, 4, 3, 7, and 8. The next question for question E. The answer for non-critical activity, we need to choose LET and EET which have different values. So non-critical activities are equal to A, B, D1, D, E, and H. And for the last question, for the answer is for total fluid, we need to use the starting node and ending node. Using this formula, we get total fluid H equals to 2. For total fluid G, it is equals to 0.
So next we move on question 4. Question A. Prepare an economically aggregate production plan for Seri Ayu Enterprise using a constant workforce strategy by varying inventory over time and allowing stock out when necessary. First, we would need to construct a table containing month forecast demand, units produced, unit excess, unit shortage, overtime unit, and inventory unit, subcontractor unit, and stock out unit. Before we can start filling in the table, we need to find the unit produced. This can be calculated by using the formula of number of workers times with working days per period time output per day. For the output per day, we need to calculate 60 minutes divided by 35 minutes and times with 7 hours. Using this formula, we get the unit produced of 9,000 units. Then we can start filling up the table for May. The forecast demand is 9,150. How do we get this number? Is by using the information in the demand table for May, which is 9,300 minus with 150, which is the last month inventory state in the question. When the forecast demand is higher than units produced, we need to state it in the unit shortage column. So for May, there is a shortage of 150 units. For June, the forecast demand is 9,000 and units produced is also 9,000. So there is no unit excess for this month. For July, the forecast demand is 8,525 and the unit produced is 9,000. So there is a unit excess of 475. This is because the forecast demand is lower than the unit produced. To get 475, we need to minus units produced with forecast demand. Then we put 475 in the end of inventory unit column. For August, the forecast demand is 10,585 and the units produced is 9,000. So there is a unit shortage of 1,585. So Seri Ayu Enterprise can use the end inventory unit of 475 from last month to cover the shortage, and then they can only produce overtime unit of 1,000 stated in the additional information. So after subtracting unit shortage with end inventory and overtime units produced, we get 110 units left. We put this in the stock out unit, which means the amount of sales opportunity that they are not able to produce. For September and October, we use the same method. So after calculating, we get this answer. For November and December, we need to add 1,000 to the forecast demand because there is additional production of 1,000 units stated in the question. Using the same methods as before, we get the unit shortage and overtime unit for November, which is 730 units, and for December, we get the unit shortage and overtime units of 800 units. Finally, we need to total up all of the columns and we get this. For question B, compute the total production cost for the period of May-December 2018. First thing first, we need to calculate the regular or normal production cost. We use this formula, which is 72,000 units times with 7 ringgit per hour times with 35 minutes per packet divided by 60 minutes per hour. The final answer is 294,000 ringgit. For overtime cost, we use this formula, 3,500 units times with 9 ringgit per hour times with 35 minutes per packet divided by 60 minutes per hour, and we got the answer is 18,375 ringgit. For inventory holding, we use this formula, which is 475 units times with 1 ringgit per packet. The answer is 475 ringgit. For the stock out, we use this formula, which is 110 ringgit times with 300 ringgit per packet. We got the answer is 330 ringgit. Finally, we need to calculate the total cost. We use this formula, which is 294,000 plus with 1,875 plus with 475 plus 330. We got the final answer is 313,180.